Okay. Goes that first blank. You guys already have it written down. Guys, for letting me know the recording. It can may focus. Do you have any questions about the spread or explain that today? Okay. We are going to talk about the center and then the overall shape of your data. Do you guys all know what the word symmetry means?
The same on both sides.
Yeah, something that cuts something in half and it's the same shape on both sides. Okay? Determining symmetry of the distribution is one way to describe the shape. If the left side of the distribution looks like the right side, the distribution is symmetrical. One word. Okay? Look at the two sets of data there. Which one is symmetrical? Left one or right one?
Right.
Why?
Because it's like a pyramid.
It's like a pyramid. Guys, here's they call this actually the line of symmetry. And then you got the same thing on both sides. This is not symmetrical. Okay? It's skewed to the right. You guys ever heard the word skewed?
I have. No.
Skewed.
Yes.
Write it down. It's an awesome word. It's skewed, this one, to the right. Bless you guys. Skewed to the right. That means too many points are moved over to the right.
Isn't that like a cluster to the right then?
Kind of a cluster, too. We're going to talk about that. Bless you. All right, so there's a typo here. Why do we need to about this? What word goes in there, people?
No.
No.
N-O.
Not N-O, but K-N-O-W. So, why do we need to know about this? All right, to describe the center and the spread of a distribution. It'd be boring if I just read this to you. Somebody read this whole paragraph to us. Who likes to read in here?
Me.
Come on, guys. Fire up.
I can't see.
Somebody besides Harrison, he participates all the time.
Fine, Albert.
Go ahead, Pedal Cow. Thank you.
The shape of a distribution tells you which measures are most appropriate for describing the center and spread of a distribution. The mean and mean absolute
Deviation, that's a hard word.
deviation are affected by outliers, while the median and interquartile
Range.
are resistant to outliers. Use the following graphic organizer to decide which measures of center and spread are most appropriate to describe a data distribution.
Very good. Guys, what that's saying is what we talked about at the beginning, where how I totally affect the mean with my age thrown into the mix. Okay? So, the mean and the mean absolute deviation are affected by outliers. So, if my age is thrown into the mix, I'm going to affect the mean and the mean absolute deviation. But the median and then the interquartile range are not affected by outliers. Okay? Here's the graphic organizer to help you keep things straight. Is the data distribution symmetrical? Can you guys answer yes or no when you see some data?
Yes.
Whether it's symmetrical or not?
Yes.
Hopefully. If you answer yes, you use the mean to describe the center, and then the mean absolute deviation to describe the spread. But we're not going to actually do those. And then, if you answer no, if it's not symmetrical, this is what happens most of the time. Put an arrow pointing to the left. Most of the time it's no. You're going to use the median to describe the center and the interquartile range to describe the spread. All right, watch how we do these. Not bad at all. You guys are totally going to get this. Boom. Next page. How many of you guys have a cat?
I do.
Is it a fat cat?
No.
Anybody have a fat
He
cat?
pukes a lot.
Is it a fat cat, Teddy? Do you have any idea how much it weighs? About?
Believe me.
Like you're going to take it to the vet and he puts it on that silly scale?
15.
Holy cow, that'd be the fattest cat in this chart.
Mine's bulimic.
15 pounds is a fat cat.
Mine is like
All right.
8 pounds.
The graph shows the
Mine's
weights of
48.
adult cats. Identify any symmetry, clusters, gaps, peaks, or outliers in this distribution. Do you guys know what the word clusters mean? Is your bedroom clustered?
Yes.
Yeah, probably a lot. It's messy, right?
Yes.
Well, maybe not messy, but just a lot of stuff in one area. Cluster. Okay.
Like a lot of furniture.
Here we go. Is this distribution symmetrical?
Sure.
No.
Yes or no?
No.
No. It is not the same on both sides. Here's where I see most of the data. It's not symmetrical. Okay. Are there any clusters? What do you guys think?
Yeah.
Where?
8 through 11.
That's exactly what we said last period. Look, guys, you got one cat. Think about how the numbers work here. You got one cat that weighs 7 pounds, and you got 2 that are 8, 2, then 3, and then you got all the way at the end. You only got one cat that weighs 12, one that weighs 14, and Teddy's cat weighs 15 pounds. Okay. So there is a cluster. You would say yes, and then just say between 8 and 11. You go by the x-axis when you describe the clusters. Is there a gap in there?
Yes.
Where?
13.
Very good. You guys are smart. Yes, at 13. There's no 13-pound cats in this situation. Okay, it's a gap. What do you guys think about outliers? I don't think there's no outliers here. Okay. If don't write this down, but what if we had one cat that weighed 25 pounds over here?
Fatty.
What chip
Okay.
cat?
That would be an outlier. Okay.
I am
It
a
would have,
tiger.
guys, it would have to be significantly bigger than any of the other data. That would be an outlier. Okay. And that would be a fat cat.
What if you have a tiger? Like a cat?
Right, it is a feline. You're right. All right, now the graph shows the heights. Let's say we took the height of all the kids in here. Let's talk about symmetry, clusters, gaps, peaks, and outliers. Okay, is that symmetrical?
71's an outlier.
No.
No. Okay, it's got to be almost perfect to say yes. Almost perfect symmetry to say yes. Okay, that one's kind of, but then this one's messed up, and there's way too many to the left. Are there any clusters?
60 through 63.
Let's see. We put yes. Most of the kids, guys, are 60 to 63 inches tall. Okay. Are there any gaps?
Yes.
There's 2 gaps. Where are they?
One is at 50.
59, and then
64 to 70.
64 to 70. There's a huge gap. Okay. Do you guys notice any outliers?
71. That would be me.
Okay.
I'm there.
It's not about you, Harrison. Remember that.
But
72.
It's not about you.
fine.
Okay.
Whatever.
Yes, there's an outlier. There's one really tall kid. That's 71. Look at that, guys. He's 8 inches taller than the next kid.
How do you know it's a he?
Don't you?
Or she. He's 8 inches taller.
Holy
Okay. Billy, question.
How come it says in the directions that it asks us about peaks, but there's no question on it?
I don't know. I didn't make these notes up. Here's my question to you. Is there a peak there?
Yeah.
Yeah, it's 61 maybe. I always think of peaks have to be like a significant peak, almost like an outlier. I mean, one more at 61 is really not a peak, but if you would describe that because that's what you see, I'd be okay with that. Great question. Hera.
Don't you have to add 72 for the gaps?
No, because there's nothing after it. Good question. Look at that. You guys see that? Should you put 72 as a gap? No. If there were another piece of data after that, yes, but because you would include 57 as a gap too, but there's nothing before that. So, all right, does that make sense? All right, last problem. You guys are
I
doing,
like this.
you guys are doing great.
Really easy.
Don't like it because it's easy.
I love it because it's not
Like
hard.
it because it's interesting.
I like it because it's
Very
not hard.
educational.
All right.
That's what I just said.
Here's,
Jack.
hey guys, here's a graph showing your map scores from your last test.
Oh God.
I just made that up. It's really not. All right. Identify any symmetry, clusters, gaps, peaks, outliers, or in the distribution. What kind of graph is that they're giving you the information? What's it called?
Scatter plots.
No, it's not a scatter plot.
Box plot.
Box plot
Box
or
and
box and
whiskers.
whisker. We called it a box plot. Okay. Now, here's the deal. Think about how box plots worked when you guys made them. Okay? You were looking for those 5 pieces of information. The min, the max, there's the median. Focus, people. Guys, the median, if all the test scores, and we went boom, 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 the 82 was the middle number. Okay? And then here's the first quartile was at 71, and the third quartile was at 86. But remember what this meant. 25% of the kids were on that whisker. Jot that down. 25% of the kids got between a 60 and a 71. Okay, it must have been a hard test or something. There's 25% of the kids are in this left rectangle. 25% of the kids, and this is tricky to understand, is in that right rectangle. And you guys always, how could 25% of the kids be in a smaller area than the other one?
Because
there's
more
a
people
lot
got it.
that.
Right, more people are in that, got that in that range, and then 25% of the people got in that upper quartile. Okay. Is it symmetrical?
Yeah.
No.
What?
This was a great example we did last period. Someone raise their hand and give me a number that's divisible by 4.
4.
16.
4. No, a big number is divisible by 4.
32.
44.
32 is a good one.
Yes, I just guessed.
32 is divisible by 4. If there were 32 kids that took that test, and I just made it divisible by 4 because I want to make it 25% of each, that means 8 kids were here, or 8 test scores, whatever way you want to think about it. 8 are here. There are 8 kids in that little box, and then 8 people got here. That's what a box and whisker shows you, okay? Because does everybody agree that 8 is 25% of 32? And we got 32 kids now? So, is it symmetrical?
Yes.
I don't think so. Because if we made the line plot with the x's,
Yeah.
you know, 60, we don't know exactly where they're at. You know, there's 72. You know, there'd be 8 x's in this big area, and then there'd be 8 x's between 82 and 86. There'd be 8 x's somewhere in between 80, but then there'd be 8 spread out. So it is not symmetrical. Okay, for it to be symmetrical, all the whiskers and the rectangles would be exactly the same size. For it to be, the picture would have to look symmetrical as well. Now, here, see if you guys get this. Are there any clusters?
Yeah.
Where? Guys, there's a cluster. Yes, in between 82 to 86. You got 8 kids in this little area that scored in that little area. Are there any gaps?
Yeah. No. Wait.
No.
No. Maybe.
You can't.
Ah, correct answer is maybe. So, what's the way to answer that question?
Maybe.
Unknown. You cannot tell. And with a box plot, your answer could be unknown. Okay. Now, are there any outliers?
Unknown.
Unknown. You don't know if exactly where they're at. This person that got a 60, okay, the low score, if all the other people got like a 70, then he'd be an out. But you don't know where they're located.
Somebody could have got 110% if it was extra credit.
Right.
I did a lot.